Assalamu alaikum warahmatullahi wabarakatuh. This is your teacher, Miss Maryam, and I hope that all of you are staying safe. So far we have done with the direct proportion, the symbol of proportionality, what is proportion, and what is the constant of proportion. Now, do you think that the directly proportional method can only be calculated and we cannot just see that graphically? There is no representation of the directly proportional method. There is a graphical representation of directly proportional methods. So we will be discussing that how to plot the values that are in direct proportion with each other on a graph, and we'll find out that if these two values are in direct relation with each other or not. So what are the techniques to find that the two quantities are in direct relation with each other, and if they are not, we will discuss this in our PPT inshallah ta'ala, and let's begin with the PPT. Alright students, so as discussed, we will be discussing the other form of the direct proportion using the graphs in today's lecture. Alright. So, as it is studied that when two quantities are in direct proportion, the graph is a straight line that goes through 0, 0. And what is 0, 0? That's actually called as the origin. If you can see that if x and y are in direct proportion, the first quantity is the first row is actually representing the x and the second row is actually representing the y. So if we see that on a horizontal axis, we are representing the quantity x, and the values for x are 0, 1, 2, 3, 4, and 5. And on the other hand, we have the other quantity which is y, and the values of y are represented as 0, 120, 240, 360, 480, and 500. And that can be shown as in graph like it's shown over here. So as you can see that the red line is actually representing the quantities, and the values have been plotted, and we have just joined all of the values, all of the plotted values together, and we got a straight line. So the straight line is actually representing that the graph is a relationship, that the graph is a relationship between two quantities that are in direct relationship with each other. All right, so this has been done by us in the class in our previous lectures, and we have done multiple examples of this one. Hope you are able to do all of the examples of this one, and we have no confusions regarding this one. Like x, if x is directly proportional to the quantity y. Okay, we have these methods which we used earlier, the unitary method and the proportion method. And if two quantities are x and y, we can say that y2 over y1 is equals to x2 over x1. And when variables are connected by equation, we can see that y is equals to kx. What is a k? The k is actually a constant, the constant of proportionality. And y and x's are basically in a direct relationship with each other. So if we write y is directly proportional to x and we want to just convert it into our equation, we will just remove the symbol of proportionality with an equal sign and a constant of proportionality, which has been done over here for you. Y is equals to kx is actually representing that equation for the direct proportion method. And these methods we have used for solving the direct proportion equations. So the other forms of direct proportion, what are these? What if the variables are connected by the equation y is equals to 3x square? What is the difference between this equation and the previous equation? The previous equation was y is equals to kx, alright, and over here it's y is equals to 3x square. The value of the k, that is constant, is you can see that it's the k is actually replaced by 3. As 3 is a constant, we can say that this 3 is actually representing the constant k. But what about this x? Previously we had the x with no power on it. That means we have just over power 1 on that x. But over here we can see that the power of x is 2, that is x square. So what should we do with this kind of equation in the direct proportion method, and how to represent this equation on a graph? So we can see that the two variables are not sharing the same index. The index of y is 1 and the index of x is 2. So the first difference over here is that the two variables that are in direct relationship with each other are not sharing the same index with each of them. So let's have a look at an example and plot it on the graph and see what is the difference caused by the index of the variables. Alright, previously we have done the plotting of the variable on the graph with the same indexes. If we talk about the equation y is equal to 3x, just simply y is equal to 3x. We had no confusion, we had no problem plotting those equation and plotting those variables on a graph. But let's see and have a look at the graph that what will happen to this one. All right, so have a look. Okay, here's a table which is actually representing some of the values. The first one is the values of the first row is actually representing the values for x. The values of x are 1, 2, 3, and 4, and the values of y are if I put the value of x in the equation y is equal to 3x square, I found it that the values of y with respect to x are 3, 12, 27, and 48. And if I just find out the ratio of these two quantities together, that is y over x, I will find those ratios as 3, 6, 9, and 12. You can see that all of these ratios are not equal and all of these ratios are of different numbers, right? Different, they are representing some different values. And we have discussed and we have done this in detail that the ratio of these quantities should be a constant one. The ratio should be a similar one. But since we are dealing with some other kind of equation, that is y is 3x square, and the variables are not sharing the same indexes. So probably there can be a situation that they may not share the same ratio. Okay, so let's have a look on the graph of this one. Okay, uh, actually it's not fulfilling the condition of direct proportion, right? The condition of the direct proportion was that the constant, that the ratio of these two quantities should be equal, and this it's not fulfilling the condition of the direct proportion. So what will happen if the condition of the direct proportion are not followed? And so what will happen to the graph of those quantities? Okay, let's have a look over here. And the first quantity is the on 1, 0 comma 3, then we have 0.5 comma 12, and then we have 1 comma 27, and again. Okay, so the quantities have the values have been plotted for you, and you can see that the graph is not a straight line. The graph is not passing through the origin. So the two basic of the graph of direct proportion which we have discussed, that the graph should be a straight line, the graph should pass through the origin, are not being fulfilled over here. So we see that if the equation y is equal to 3x square, we cannot just plot a graph with the variable of y and x, and we cannot just simply ignore the index of the variable if it's not equal to the index of the other variable. All right, if we do so, we can see that the graph of those quantities are not showing that this is the direct proportion method. Okay, so the curve is not representing the direct proportion method. It should be a straight line. All right, so y against x square. Previously it was y against x. So the first row is representing the x square, the second row is representing the y, and the third row is representing y over x square. Okay, remember that previously we have done the values of y and x. We just plotted the value of x against the values of y, but over here we are finding the values for x square and finding the ratio of y and x square, not y and x. Okay, so over here we can see that if the values of x square are 1, 4, 9, and 16, the values of y are 3, 12, 27, and 48. We just put the values of a y in the equation and we found the values of the x square. Vice versa, we can do the other way as well. Okay, so the ratio or the proportion of y over x square has been found out for you, and we can see that the ratio of y over x square for every value, for every entry, is equals to 3. We can see that the ratio between these variables is same over here, and that's the major difference between this example and the previous example. The previous example, the ratio of y and x was not same for every value. Alright, so over here we can see that the ratio is similar for every value. Alright, and this means that this is fulfilling the condition of the direct proportion method. The constant of proportionality should be constant, right? It should not be a variable. Yes, over here we can see that the constant of proportionality is 3. So if we plot these values, we can see that this is a straight line. It's a straight curve, and if we just um, if we just stretch our line to the towards the origin, we can see simply that this will pass through the origin, which will fulfill the condition of the direct proportion. All right, so it's not a curve. That means it is representing the y quantities y and x square are in direct proportion with each other, and it will pass through the origin if you just stretch this line towards the origin. So from the investigation, when y is equal to 3x square, y is not directly proportional to x because y over x is equal to 3x is not a constant. However, y is directly proportional to x squared because y upon x square is equals to 3 is a constant. Alright, so this is the investigation which we have just done over here. So other forms of direct proportion, we can see that earlier we used the unitary method and the proportion method to solve the direct proportion problems. There we had those variables which were sharing the same indexes with the same powers. Now we will be using the algebraic method to solve the direct proportion problems. All right. The y is equal to 3x square, we can just not simply solve it with the help of the unitary method or the proportion method. We have to apply those algebraic methods which we have just done in our previous classes, like in class 6 and class 7 also. We will just recall all of the concepts of the algebra, and we'll be applying those concepts over here to find the values of the two quantities, and then we will be plotting the values on a graph to see that if it is representing the two values are in direct relationship with each other or not. Okay, so we have covered a new topic today, that is how graph works with the direct proportion method. So we will be covering the multiple examples of the graphical representation of the direct proportional quantities in the next classes as well. So do come up with any of your query which is related to the graphs, and hope take care and Allah Hafiz.